G'day guys, today we're going to make our voxels a little bit more efficient. The way we've got it at the moment, we're just rendering a single face, sorry, I should say a single quad for each side of our cubes. What I'm going to do is just break my shader so you can see. You can see every face just has one triangle, two triangles, that's called a quad. And it's great for these little bits here, it's about as good as you can do, but when you've got a huge flat area like this, you look at it and think, well, that could be one big square, just two big triangles. And that's exactly what we're going to do. You can see, especially on the sides here, we've got lots of triangles. So what we're going to do, we're going to use something called greedy meshing. And I'm going to turn it on now to show you what it does. And it's probably hard for you guys to see, but that is one big triangle right there. You can see it here. It's one big square there, where that would have been like 1, 2, 3, 4 by like 8 to 10 before. So this, I checked it, it makes it about 80% more efficient in triangles. Of course, less so for when you're doing detailed parts like this, but for big flat areas especially, we use far fewer polygons. It does take a little bit longer to actually compute it all. It's something like 30 or 40% longer, but I think it's worth it for me to get this more efficient. Now let me turn the that back on. And you will notice the color looks a little bit different, and I do have this shader. That's something else we're going to have to work on today, because since we're not doing a simple, every single one is a square, we've got to be a bit more fancy with the way we do our UV mapping. But we'll get to that. For now, let's go and learn how to do a greedy mesh. All right, so I'm back to where we left off in the previous video now. And I'm actually going to turn off the ramps. I'm not going to be doing greedy meshing for the ramps. We could, that could save a bit of space, but it's just a bit too much work for now and don't think we need it. So the ramps will still work, and I should have showed you in the video earlier. We're just not going to be playing with them right now, so I'm just going to turn them off. They'll be generated as usual. All right, so let's go and have a look at our chunking. Now, right now, all the action happens in this generate chunk mesh. And right now, we just go, hey, loop through every single cube in there, every single block, and we just generate the cube mesh, which just passes off the job to the actual block itself. So every different kind of block, including the dirt, the ramp, and the different kinds of ramps, they all draw their own faces. Now, we're not going to be able to do that anymore because, of course, multiple blocks are going to share the same face. So we're going to have to do it in the chunk. So the way we do it is like this. So if you can imagine, we've got a big face like that. And right now it's like this. And let's just say this spot here is air, and this one as well. So we don't need to render those ones. What we do is we basically check here. Is this a block? Is this a face we will draw? And if it's yes, we check the one next to it as well. And that would be a yes, and we check the one next to it as well. That would be a yes. We're rendering this one, this one, this one. When we get to here, we realize, oh, we're not rendering that one, so that's the maximum width of this face. So then what we do is we take those three and we go up all at once. Can we do it? Yes, yes, yes. Can we do it? Yes, yes, yes. Can we do it? Yes, yes, yes. Can we do it? No, no, no. And so basically, we've got a width of 3 and a height of 4, and that information we store, and now we would also know the position of 0, 0. So basically, we're going to have this information 0x, 0y, 3 width, 4 height. We take that information and we're going to now go and draw that face. And then we do the next one. So we look at this position, which is x is 0, 1, 2, 3, 4. So x 4, y 0. And we go, yep, yep. So a width of 2. And we do the same thing. Yes, 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 yes. And that's a height of 4. So we take that information to go and build another face. And then we keep checking going, all right, this one's already seen, this one's seen, so we ignore, ignore, ignore until we get to here. And we do the same thing. We go the X position, which is 0, 1, 2, 3. The height is 0, 1, 2, 3. It would only be a width of 1 and would be a height of 2. So once we've checked the whole thing, we're going to have a list of these little mesh data entries, and then we'll use those to build up a face. So it's not that hard, but there's a few steps to it. So what we'll do first is I'll just make that little, so we've got all these variables to hold our mesh information. We'll make a new one, mesh data, which is just an array. All right, back down to where we generate our chunks, and we'll do the same thing. We'll grab that mesh data and we'll reset it back to nothing whenever we regenerate the chunks. All right, so basically we're going to do this loop. We'll just turn off generate cube meshes for now. And we're going to make one more little variable called visited, which is going to be a dictionary, and it's just going to keep track of every cube that we've already checked. So we don't check them twice, 3 times, 4 times. And so what we'll do is we'll go through each position and say, hey, have we visited that? So we go if visited.has vector3 xyz. So that way, if we've already visited, if we not have visited it, then we'll ignore it. Actually, let me do this backwards. We'll say if we visited, we'll continue, which means it will just skip and go to the next one. And that'll save me having another bloody nested thing. And if we haven't visited, let's just go visited vector3 xyz. And let's just go equals true. All right, so if we have visited already, we'll skip it. And now we're looking at it, we'll just automatically say we visited it. And so now we're making our first mesh data, which will start at this position. So we go var width equals 1, height equals 1, that's the minimum. Now I need to check if a cube is visible, and that's going to be quite a thing. So let's make a little function for it, and let's just call it is solid. Solid, and so we're going to need to know the position, which is x and a y and a z, and we also need to know its direction, because of course we're looking at a cube and we're only going to be doing one face at a time. We need to say, all right, is there anything in front of this one? Because if there's another cube sort of here, then we're not going to draw that one. So we need to check to make sure there's nothing here. We're only going to draw it if there's air here, basically. And so what we need to do is check, is it basically a dirt block? So we go get block vector3 I x y z dot get block type equals block type dot dirt, and not block covers adjacent wall, which is the one it's a function we've already made to check if the block adjacent to it is covered. So we're going to do the same thing, vector3 xyz, but we add to that the direction, because the direction is going to be something like vector3 -1 0 0. So basically we're going to check this block plus 1 to the left or 1 to the right. That's how the direction works. All right, so that'll check to make sure the current block is actually dirt and the one next to it isn't dirt. So if that's the case, then that's a face we're going to draw. So that should do it. So let's say we're going to skip it if it's already visited, or we're going to skip it if it's not is solid, x, y, z. And the direction, what we're going to do, we're going to actually have to do this a few times, once for each direction. So let's start it with var dir equals vector3 0 0 1, so that's x, y, z. So we're going to check first basically x positive, z positive. So we're checking z positive. We're checking if there's anything in that direction, which we're calling south so far. And let's just say that. Let's say we're doing south first, because we will have to go through this for each direction. All right, so we've established now that, let me go all the way back and we'll do one at a time. All right, so we've established, I can't go Control Z anymore, so let's say we're doing this one. So right now, let's say we're at this one. And we know this one's good, so we've got a minimum width where our position is X, Y, sorry, our position is 0, 1, 2, 3, 4. So we're at 4, x, y, 0. The width is already 1, and the height is 1. And we need to work out how far to the right we can go. So we need to basically go check, 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 check until we can't go any further. And we're going to use a while loop for that. So we'll go while x plus width is less than chunk size and is solid x plus width y z direction. Okay, so while we haven't reached the edge of the map, and if the one we're just checking is solid, and we also need to make sure the one we're checking hasn't been visited already, and not visited dot has vector 3 x plus width y z. And so if that's all good, what we'll do is we'll go visited, and we'll add that one we've just checked, and we'll say it's true. So now we have visited plus width plus equals 1. So what we just did, we went, all right, jump 1 to the right, check if it's solid, check if it's a face we actually need to draw, check if we haven't already checked it, and if it's all good, we will go width is now 2, which means we've included this one as well. And that would keep going again, till we get to the end of the map, which we've reached the end of the map. So now we've got a width of 2. Now what we need to do is make it so it checks these two simultaneously. Because let's say this one's good, but this one's not, we should not go up because we can't draw an L-shaped thing. We're only drawing squares, only drawing quads. So now that we've got the width, we need to move up on the y. So let's go 4, let's call it ry in range y plus 1 chunk size. And what we'll do is I'll just have a little tag saying the row is good. And by default, the row is good. The row is only bad if it turns out to be bad. So we're going to start basically on y plus 1. So we're starting here. We're going to check the whole row. And if we're ever coming into any problems, we'll mark row good as false. So we need to go through x again for rx in range x to x plus width. So we're going to check from the x position to the x width, or the x position plus the x width. And then this same sort of thing. So it's going to be if not is solid rx, ry, z direction, or, whoops. So if it's not solid, or it's been visited, let's say it's rx, ry, so it's row x, row y is why I've picked that, and direction. So if it's not solid or it's been visited, we're going to say row good equals false, and that'll be the end of it basically. We won't check any further. If they would say that, we go check, check, oh, this one's no good, row bad, so we'll just stick with this. Or if we'd had y, we've done y, if we've done height is 1, height is 2, height is 3, and when we hit here, we can't go any further. We wouldn't do height is 4, so height is 5, and we'd cancel there. So now we just go, after we've done that, if row good, height plus equals 1. So we'll add 1 to our height, and then we need to just run through and make sure that all the ones we've just checked in that new row are also marked as visited. So for basically this same thing again. Visited vector 3 rx ry z equals true. Now what have I done here? Oh, sorry, shouldn't be direction in my visited thing. All right, and if row is not good, we'll just break it, and then we'll finish doing that block. And so now we've basically got all the information. We've got the x and y position, sorry, the x, y, z position. We've got the width, we've got the height, and we've got the direction. So that's everything we need to know to build that face. So what I'm going to do, we need to fill up mesh data. What I'm going to do is actually make a little function for that. Now, bugger it, we'll just go, all right, mesh data dot append, and we're going to go add x, y, z, width, height, and direction. Oh, sorry, not direction, direction. All right, so that'll go through and make all the faces, make all the quads, I should say. And let's just go at the end. Let's just go print mesh data and see what we come up with. So for testing, I don't want to do so many. Let's just make it so we're doing 1 by 1 by 1. So just one chunk and generate. All right, and you can see we've got x and y 0, width of 11, height of 3, direction, sorry, x, y, z 11, width of 3, height of 1, and the direction. This looks like it's working. So you can see 0, 1, 0. So it's hard to know if this is exactly what we want, but now we've got this information. Let's go and draw the face. And the way we draw the faces, what we'll do is we'll first need to, let's say, draw quads. Whoops. And we'll just go for quad in mesh data. And let's break up the information. So for each one, we've got the position is vector, is vector 3. And we're just basically getting this information back out. So it's quad number 0, quad number 1, and quad number 2. We've got the position. We need the width equals quad number 3. Height, height equals quad number 4. And I've already got direction, so let's just go direction equals quad number 5. And we're going to go if dir equals, which will always be right now, vector 3, 0, 0, 1. So basically south. We need to draw it. And what I'm going to do, I'm going to go to my block. Let's make sure we got the basic dirt block. Yep. And we find how we draw south facing vertices. And let's just steal that one. And so we're already in the chunk, so we can delete that. And we'll just go the normal not is top block. All right, so that should all still work. And the only thing we've got to change is the size of our face. So right now, the way it works, they're all going by -5 or +5. What's happening is you've got a position, and to draw our face, we go from here, so it's a -5, -5, to here, which is +5, and then here, which is +5, +5. That's how it works. So what we're going to do is basically keep this position and this position. Sorry, I take that back. We're going to keep this position, but this one is going to be extended out by the width, and these two are going to be extended out by the height, by basically this one. And then instead of having this little guy, we'll end up having something like that. Or bump, 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 I should say something like that. So we just go basically all our positives. Let's see, x, y is the height. So x, y, z, so y is the height. That one will be the height. And x is the width. All right. Let me just space this out a bit so it's a bit more readable. So we're not doing anything with z. All right, I think, is that it? I think that should draw some faces now. Let's see, we should get that south face. And we did. Bit of an error there, not sure what's going on there, but you can see. Oh, they're all just one too big. Oh, math error, it's all right. These should all be minus 1, minus 1, minus 1, minus 1. Perfect. So you can see this is all the south side faces. Now we can actually check to make sure it's all correct by just going back up here, and let's actually turn this back on and generate the cubes in the old-fashioned way at the same time. So let's just see, we should have a hole here, and yeah, you can see what's happened here. It looks like it's worked. Let's go back one more time. Yeah, that looks like we're getting the correct, what we'd expect. Let's have a look at this one. So we've got a face here. Yeah, I think that's working perfectly. All right, so now we've got south face. We need to, and here's the tricky bit, we need to basically just grab this whole guy here. And now we're going to go -1. And we do the same thing for north. Oh, we also have to forget everything we've visited, because we're basically doing the same thing again, checking everything from the other side. And for north, I don't think there's actually any difference here. It'll be different for when we're doing east and west and up and down, because instead of searching X and Y, we'll be traveling. So let me show you what I'm talking about. For this one, we're checking, you can see on the X axis and the Y axis to test. When we're over here, we're going to be checking the Z axis and the Y axis and ignoring the X one. And when we're on the top, we're going to be checking the Z and X axes and ignoring the Y. But yeah, right now we're checking, right now we're checking X and Y, and we're just going around and checking from the other side. So we'll just count from here up, and we're just checking in the other direction. So nothing's going to change, but what will change is the drawing of it. And let's just do the same thing. Let's go to our block. Looking for north. And same thing, we've got add our height +1 to here. Add our width +1 to here. So just making this more readable. All right, let's see if that worked. Oh, so I need to turn off the regular cubes. Huh? Should I not save it? Oh, what's going on? Oh, I know. I copied and pasted that one, so it's in there twice. All right. So I don't do that again. Let's just keep this one separate. So if I want to turn it back on, I can just go up here and do it. All right. And we've got the south side, and we've got the north side. I feel like there should be a face here. Let me get rid of that tree. Let's see what it should look like. Yeah, we should have a big old face right here. No reason there shouldn't be. All right, so what have I done wrong? Oh, I know. Because I copied and pasted here. This one, for the normals, we're actually going off the direction. So let's just, so that should be -1, but I can just put the direction here, which is what I should do. Oh, of course. That's the way. So now we have the north side, and we've got the south side. And you can see we've got all these inner ones here. All right, now the tedious part is where we have to just do this for all sides. So let's go and do another one. And let's do east. And east is +1 on the x. And like I said, since we're going, so we are like this now, we're going positive on the x, we're looking in the x direction, which means we're over here, looking in the positive x, which means we're checking now on the z axis and y axis. So our width axis is now z. So basically in here, we're going to go, well, z plus width, and we're going to add our width to z instead. Y is still our up and down, but we're looping through, it's going to be not rx, but rz. So basically everything that was an x is now a z. RZ. All right, I think that's right. And now we need to just do this for east. Oops. And so we go back to our block, we find this one's for drawing east. And so what we're going to do is our width is going to be added now to the z's. And the height is going to be added still to the positive y's. And let's give that a go. Oh, there's some error there. You can see we basically made the same face lots of times, but we have actually got the faces. So there's some error, but we've got the correct faces. Let's just do a check with our original cube method. And yes, we've got the right faces. I've just got some error, which is checking these. Oh, I see. I've just done my visited ones wrong here. I forgot to add that to the Z instead. And yep, that did it. Look at that. So that was like 32 by 30, sorry, 16 by 16 before. Now it's like a one big guy. So we're saving a heaps of triangles here. All right. I might fast forward this for you guys and you can just go look in the Git, but let me just quickly get this going. So for east, west is going to be the same. We just need to do this differently. All right, that works. Now we just need the top and the bottom. So what I'm doing here, I'll just make sure I copied the south one because we're going to keep X for our width, but we're going to use Z for our height. So everything is a Y here is going to be a Z. So RZ, Z plus equals Still going to be Rx. Instead of Ry, it's going to be Rz. All right, I think that's good. So we're going to be checking sort of the X and the Z. All right, for top. Now top uses a different texture, so we need to actually do the different add UVs for this one. All right, now it's going to be, what is it? Z is my up down, Z is my height, and X is my width. All right, let's see how that goes. All right, yep, we can see we've got grass on the top. Now you will notice that my big faces, it's stretched, and my small ones, it's small. So that's something we've got to look at later. That's a bit of a problem because we're not tiling simply anymore. We're stretching what is a square texture that should cover one tile over, you know, an arbitrary width and height. We need to fix that separately. Let's finally just do our bottom. So -1 here, and that's what we've got to change aside from the drawing. And it's going to be dirt as well. So what I'll do is I'll just steal one from the west, bottom, because it'll have the same UVs. From the block, I need to add the bottom. There we go. Z is my height, and X is my width, and oh, that didn't work. What did I do wrong there? Oh, just got this one set wrong. That should be 0 and -1 for the direction. And that's it. Let's go in here. Yep, everything is drawn perfectly. Got no missing faces, and it's much more efficient now. All right, let's try generating a whole bunch of them. And you can see it still generates pretty quickly. I won't show you the timing difference now, but like I said, what was taking 5 seconds to do before with quite a big map was becoming like 7-8 seconds, but you can see it's still pretty fast. It only gets really long if you're doing quite big maps, which to be honest, you'd probably do. So you might need to in-game have a bit to load. But if we go and play, just letting everything load. Once it's loaded, we're nice and smooth, and we should be able to, yes, we can delete things, and you can see it's still pretty fast. I'm not able to add for some reason. I'll find out why that is, but yeah, so that's it. We've just done the greedy meshing algorithm. Everything is really quick now. We've got far fewer polygons. And even though it takes a little bit longer to set everything up in the first place, you can always, if your computer's running a bit slow, you can always make the chunks smaller. It'll take a little bit longer to actually load the whole thing. But when you're clicking on a chunk and having to rebuild it in game, that'll be a little bit quicker. It'll depend on your game and what you want to do. To be honest, you can probably still just do full size 32 by 32 chunks. Let me load that. I definitely want to hide this behind a loading screen. Yeah, so you can see 32 by 32 chunks are a bit big for my computer to handle. But if we do 16s, you can see it slows my computer down a little bit, but you can still be doing something while that's happening. And then yeah, you can see perfectly smooth as soon as it's done. If we do 8 by 8s, you can see it's still perfectly smooth even as they're loading. And just to show you, I can actually do, you just make it like that. Have a whole bunch of really small chunks. Yeah, but that's what you can do. If you find that they take a little bit too long to make, you can just change the size of your chunks. You can see it does slow mine down a little bit when I'm doing 16s. All right, and let me just see if that's the same in game. Yeah, so a little bit chunky when we're still loading. So if you need to do it while the game's running, you'll probably make the chunks a bit smaller. But if you hide it behind a load screen, that'll be fine. All right, so there, we still have to fix, you can see the pixelation on this really stretched mesh and this squish one. You can see when I delete one, you can see it turn into this mesh here, this one here. So I'll show you how to fix that. It's not that trivial. We actually have to make a new shader. So there's not really time for that now. I'll show you that in the next video. All right, thanks for hanging around, guys. I'll see you later.